that means that we are going to be somewhere between 17 and 21 inches of vacuum. Now, if I was up in Big Bear, here in Southern California, which is about 8,000 feet elevation, okay, that's going to put us somewhere between 10 and 16 inches of vacuum, if my math serves me right, which most of the time doesn't. So that right there would let me know that the engine's ability to breathe is going to be a lot different at a denser altitude than down here. Okay, so that's important for me to understand that. Now, one of the simple tests we could do is we put a vacuum gauge and we can see that we're getting a 1-inch drop. Okay, that's usually going to be an indication of a valve seating problem. So if you see it do boom, 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 it's going to be a valve seating problem. Okay, another thing you can actually do is the dollar bill test. Grab a dollar bill, slam it in the exhaust. If you have all cylinders contributing properly, they're going to be puffing out pressure into the exhaust. That dollar bill should be out the entire time. If every so often you see a suck back, okay, that means that you had a cylinder that didn't contribute, and usually going to be indicative of a valve problem. Okay, so keep that in mind. The other test we could do is if we have a slight vibration, okay, slightly below normal, and the needle gauge will vibrate rapidly at idle and then stabilize at high speeds, is going to be a worn intake valve guide. Okay, so what you're going to do is if you're watching your vacuum gauge at idle and you see the needle doing this, and then once you bring it up to about 2,000 RPM, it stables off, that's going to tell you that you have a worn valve guide. From what my students are reporting back, there is quite a bit of questions on this on the A8, so just keep this in mind, and you guys can go back to this if you need more help on it. This way you guys can get it down packed. Also, I recommend that don't only use this information just for the ASC. This is actually stuff that I use in my diagnostic strategies and I teach in my diagnostic class. So this is not anything that's just for a test and then forget about it. This is for something you guys need to pick up, master for the test, but also make sure you're applying this, because these tests are really going to help you guys be able to test vehicles and properly diagnose and repair cars. Okay, so if I have an intake vacuum leak, okay, usually I'm going to see about a steady 3 to 9 inches, somewhere in that range. All right, we used to use this and see this a lot back in the old day when we had vehicles with
directional
AC
volume
systems that were operated with vacuum controls. Okay, now we just use smoke machines. But that was one of the ways we used to check back in the day. And propane rigs were a wonder back then, which I still use my propane rig today. All right, if you have a valve spring problem, you want to increase the engine speed to about 2,000 RPM and check for weak or broken valve springs. If the vacuum gauge needle fluctuates rapidly between 12 and 24 inches of vacuum, okay, then that's usually going to indicate you have a weak valve spring. Another way that we can actually do this is by doing secondary ignition. With secondary ignition, if you guys have taken any type of secondary ignition class or if you guys have studied it on your own, KV is going to be our indicator of actual compression. So one thing that you can actually do is bring the RPM up to about 2,000 RPM and then let it go. And when that happens, that throttle is going to come back and shut off, and we should have a spike in KV. And if we have a one cylinder that takes a little while longer to spike up, then that's usually going to be indicative of a valve spring problem. Okay, so you can also see that in secondary ignition. And if we have a restricted exhaust, one of the ways that I test for it, and I was taught to test for it, and it's worked very well for me, is you plug your vacuum gauge in, start the engine, let it come to normal speed, and then you're going to do a wide open or a snap throttle. What's happening here is we're actually going to 3, 2, you're going to snap the throttle. Vacuum should drop to 0 because there's so much inrush of air that intake manifold and atmospheric pressure are equal. So you're going to see 0, and then it's going to come back over your steady vacuum and then stable back off at your normal vacuum. That's a normal engine operation. Now, if the exhaust is restricted, what you're going to see is instead of vacuum dropping off to 0, vacuum's actually going to increase. So as vacuum begins to increase, then it's going to come back off to normal. That's telling you that you have a restricted exhaust. Exhaust is actually not flowing out the tailpipe, which is why it's actually increasing in vacuum. Keep that in mind. Okay. Actually, let me go back real quick. Here in my class, I actually taught my students to use an in-cylinder pressure transducer. So this test only works if you have one cat. If you got a car that has multiple banks and multiple cats, then an in-cylinder pressure waveform will probably be your best bet. What you're going to do is if you have a V-style engine with 2 banks of cats and you suspect one bank to be plugged or restricted, pull the plug on that side, drop in a transducer, run a test. Remember, your exhaust plateau needs to be relatively even at atmospheric pressure. If you begin to see it actually curve up or ramp up and then come back down into vacuum, that's usually going to be indicative of restricted exhaust. So if you have a vehicle that has multiple banks, this is how you're going to figure out which bank is actually the one that has the restricted exhaust. So you guys are seeing here, this is actually a test that we teach and we use quite often here during class. This is a relative compression test, or an RC test. So one thing that I teach in diagnostics is you got to know the difference between a general test and a pinpoint test, or how are you using this test. And what I mean by that is this relative compression test gives me a general idea of how well the engine is doing. Okay, so when a car comes in and it has a misfire, this is the first test I actually run. Why? Because if it shows that I have a weak cylinder, why am I going to waste my time on fuel and ignition? I need to now run pinpoint tests to determine which cylinder is bad and why is it bad. Okay, so run an RC test to quickly determine if you have a weak cylinder. One other thing is listen for it. Okay, I can't tell you guys how many times I get called to diagnostics or a diag at a shop, and I show up and I go to hit the key, and instead of hearing a ta 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 engine cadence, I hear it ta 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 ta. It's like, bro, did you not hear that? And they say, oh yeah, don't worry about it. It has a